Deep Silicon VLSI YouTube channel. In this video, we are going to discuss about 2's complement representation and beyond that. Yes, this is one of the best question to challenge your ability in 2's complement representation. Let's dive into the question. Number 34. P is a 16-bit integer. The 2's complement representation of P is F87B base 16. The 2's complement representation of 8 into P is C3D8, 187B, F878, 987B base 16. Guys, every question has different solutions. Every problem has different solutions. Likewise, even this question also has two different solutions. Let's see method 1, the first one. Here he told P is a 16-bit integer and the 2's complement representation of that P is F87B. Now let's find out the binary representation. If it is F87B, the binary representation is 1111, 1000, 0111, 1011. This is the 2's complement representation in binary sequence. Guys, how to find out the decimal value of this? Because you need to do 8 into P now. If you have the P value in decimal, so that you can multiply and you can tell the decimal value. Of course, again we will convert into 2's complement. Anyway, he is asking the 2's complement representation of 8 into P. Now, if you take this and MSB, if MSB is 1, what it is? It is a negative number. And if you want to get the decimal value, apply one more time 2's complement, then convert into decimal. If you do that, means if you apply 2's complement here, it's 1, 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 0. This is now in like the true form. Then you convert into decimal. The value is 1925. 1925 base 10. Now guys, what to do? Now you got the P value. Next, we need to do 8 into P. 8 into P. What is that? 8 into minus 1925. 1925 base 10. Then the answer will be like the decimal value minus 15400. This one. Now you got the decimal value. Now we need to convert this into 2's complement because he is asking 2's complement representation. Now if you take this, it's a negative number now. Therefore here it requires 2 steps. We need to write the magnitude bits along with the sign bit 0. Because it's a negative, it requires 2 steps. Again for that we need to apply 2's complement including sign bit. Then means here you convert this 15400 into binary including sign bit. If you represent, then the binary sequence is like 0011 1100 0010 1000. This is the one. This is the sign bit. And here if you take this again into magnitude, this is a magnitude information regarding 15400, right? As the options contains 16 bits because 4 hexadecimal digits are there, so that here you require this 0 between the sign bit and the magnitude bits. Fine, we got this. Again we need to apply 1's complement, 2's complement. Therefore it is like 0001. Then 1011, 1100, 0011. This one guys. So we got the 2's complement representation of minus 15400 base 10. Now in the options hexadecimal, right? Then again you convert into hexadecimal. Therefore it is C and again it is 3D8. So guys, everybody, the 15,400 minus 15,400, which is 8 into P in 2's complement representation in terms of hexadecimal form is C3D8. Hence, the right answer is option A, C3D8. But guys, you only observe how many efforts we have to put to reach the answer. You need to convert into decimal. Again, you need to multiply. Again, you need to convert into magnitude. 15,400. How much time it will take? Again, getting the 2's complement. Again, converting into hexadecimal. This is method 1. Let's see method 2. Guys, here, what is the P in 2's complement form? F87B. Let's convert into binary. Therefore, it is 1111, 1000, 0111, 1011. Right? Now, guys, you know shift left operation, shift right operation. Let's consider 0001. Now you do shift left operation one time. Then what you get? This 0 go outside. This 0 will come here, here. This 1 will come here. And the new 0 will be added. It is 2. If the decimal value is 1, the decimal value is 2. Means here, if there is a binary sequence, if you do shift left operation one time, the value gets multiplied by 2. Similarly, you do another time, so that this 0 goes outside, so that 010, here 0 will be added, the new 0. Then what is the value? 4. What I mean, guys, for a particular binary sequence, if you do shift left one time, then the value gets multiplied by 2. 2 times, the value gets multiplied by 4, means 2 power 2. So here, based on that concept, we can give the solution here in fraction of seconds. Yes. Now, here what he told, 8 into P, na? So let's write 8 into P. This 8 into P can be written as 2 power 3 into P only, na? Yes. If you want to multiply the P value into 2 power 3, it is similar to performing shift left operation 3 times. Yes, that is equal to 2 power 3 into P only. Now, let's take this sequence. You do shift left one time. Therefore, this one go outside, so that it is 111, and this one will be added here. Again here 0000, 1111, 011. The fresh 0 will be added as LSB. So it is equal to 2 power 1 into P. Okay guys, again here you do shift left one more time. Here 1110, 0001, 1110, 110. Again one more fresh 0 will be added. It is equal to 2 power 2, because till now 2 times shift left has been done. Then it is 2 power 2 into P. So finally guys, one more time shift left, so that it is 110, 0, 0011, 110, 100. A fresh 0 will be added here. It is equal to 2 power 3 into P, because for the P sequence we have done shift left 3 times. Finally we got this sequence. Now here if you convert into hexadecimal form, you will get the answer, because we didn't go away from the 2's complement to decimal again. No, we are still in 2's complement only. Of course, we have performed like shift left operation. Now, when you take it into hexadecimal form, 1100, C3D8 in hexadecimal. C3D8 option, like base 16. In this way, guys, we can complete this particular question in a fraction of seconds. You need to know this hack definitely, because guys, in off-campus placements, they conduct some hiring test. in that test paper definitely you can expect these kind of questions. It may looks huge, but it requires very less amount of time if you know the tricks how to solve them, right? So this is what regarding the 2's complement representation, much more. See you in the next video. This is Shivaram signing off. Jai Hind.